Two of the key concepts in measurement and appraisal are the ideas of reliability and validity. Reliability is the idea that a test measures something consistently. Validity is whether the test is actually measuring what we are intending to measure. For instance, I can measure the circumference of your head very reliably and accurately with a tape measure. But if I said that instead of giving a midterm, I was going to determine whether you learned anything in class by measuring your head circumference at the beginning and then at the middle of the semester, you would likely argue with me and say that wasn't a valid measure of your learning. I can measure head circumference reliably, but that doesn't mean it's a valid measure of the construct. In testing, we definitely need for our measures to be consistent so that we can get the same score each time. Of course, some traits change over time, so the measure might be reliable from day to day, but not from year to year. For instance, depression. You might score the same on a Beck depression inventory today and tomorrow, but your score might be very different in a month or a year. Intelligence is different. Your IQ should not vary much from year to year, but it might vary over 10 years or 20 years, particularly if the first measure was when you were in preschool. The test developer and the test user has to determine how much variability is expected in order to determine how much reliability or what type of reliability is important in a test. Another thing to remember with reliability is that we are measuring unsystematic errors, not systematic ones. If I test you in English, but you mainly speak Spanish, you might make the same score each time I test you, so the test appears to be reliable, but in fact it's not measuring the construct at all. It's not valid. Speaking a different language is an example of a systematic error. It's not accounted for by measuring reliability. Another example is a bathroom scale that's always 10 pounds off. It's reliable, but it's not right. It's not valid. Both reliability and validity are measured by doing various kinds of bivariate correlations and obtaining a correlation coefficient, which could be called a reliability coefficient or a validity coefficient, depending on what you're comparing. Look at the next slide just to remind yourself what a bivariate correlation looks like. If the dots on the graph go up and to the right, that's a positive correlation. If they're down and to the right, then it's a negative correlation. If the dots are widely scattered across the graph, then the correlation is weaker. If they approximate a straighter line, then the correlation is stronger. Correlations vary from 0 to 1, so a stronger correlation is closer to +1 or -1. A weaker correlation is closer to 0. Some sources of unreliability in testing are in the test scoring. Maybe the person or machine scoring the test is making random mistakes because they're tired or the machine is shorting out. Another source is test content. Maybe one classroom test covers different items than another test. Maybe the teacher makes up a different test for each class, so there's no consistency in the way she's measuring learning. Another source of unreliability is test administration conditions. Maybe sometimes the room is too hot or sometimes too cold. Maybe sometimes the students have an extra half hour and sometimes they don't. The last source is the person themselves. Maybe you were sick when you took the test or you didn't get any sleep the night before. But the next time you're feeling better. You got plenty of sleep. Your scores may vary because of your personal condition. When we talk about reliability, we're assuming some concepts from classical test theory. The basic idea is that you have a true score on a test, which would be your ideal score if everything went exactly right. But that never happens. Sometimes you forget something you really knew because you're tired. Sometimes you miscode the Scantron. Sometimes you miss the not in the question stem and mistakenly choose the wrong answer. Sometimes you don't know the answer, and so you guess, and you guess right. Hooray! But what happens is your obtained score is not exactly the same as what your true score would be. It's off by some degree of error, your mistakes or guesses. The idea of classical test theory is that the true score equals the obtained or observed score plus or minus the error. If you're following along in your book, you'll find this information toward the end of your Hogan Chapter 4, but it makes more sense here in the presentation. When we're examining the error in a test, like we talked about a minute ago, we use the standard error of measurement, or the SEM. The SEM refers to the band of scores around a person's score that still reflects the same thing. So you might have a score of 100 plus or minus 3. The plus or minus 3 is the error. The SEM equals 3 in that case. That's also called the confidence interval. So if you score 100 on one day, and 103 on the next day, and 97 on the next day, that's to be expected. Those are all actually the same score because of the SEM. There are four main ways of measuring reliability. The first one is test-retest reliability. To get this coefficient, the test developer gave the test to a group one day, and then after some specific period of time, maybe a week, they gave the same group the same test again. And then they calculated a correlation coefficient between the two sets of scores to see how well they're correlated. This type of reliability accounts for personal conditions at different times. One problem with it is that people may remember the first administration of the test and try to answer the same, or they may have learned something from it, which changed their score. That's called carryover effects or practice effects, and that's a problem. This is just an example of what the data would look like from a typical test-retest reliability study. Another type of reliability is called interscorer or Interrater reliability. This is used especially when you have a test that is scored more subjectively. For instance, if you were scoring a dance contest, you would want to have several judges because each one may have different opinions about what good dancing looks like. But each judge's score would likely be a little different. When we're measuring psychological variables with a test, we want to make sure that all the different scorers or raters or judges score the same. So we measure inter-rater reliability. Again, when we take the scores from one rater and find the correlation between those scores and those of another rater, then we have an inter-rater reliability coefficient. Sometimes the test developer will make an alternate form of a test, or a parallel form, test A and test B, maybe to avoid the carryover or practice effects. But the developer wants to make sure that both tests are measuring consistently. So they will compare the scores from test A to those of test B. Sometimes they give them at the same time so that it can account for differences in content. Sometimes they give them with some time in between, so they can account for differences in content as well as differences in personal conditions. The last type of reliability is called internal consistency reliability. This is a very popular way of measuring reliability because it can be done in one administration of the test. One way is to correlate all the items together, two at a time, and then correlate them to the total score. This is called the Coulter-Richardson method. Another way is to split the test in half, usually the odd-numbered versus the even-numbered items, and then compare the scores from the two different halves. The name of the reliability coefficient in internal consistency is called Cronbach's alpha. But don't get confused by the name. It doesn't have anything to do with any other alpha. It's just a name. Finally, when looking at reliability, it's important to remember that in general, a longer test is more reliable than a shorter one. Consider whether you would rather have a midterm that has 5 questions or one that has 50 questions. The problem with only 5 questions is that you might not have studied those particular concepts very well. When there are 50 questions, you're more likely to at least get some right. In other words, it's a more reliable measure of your knowledge.